Welcome, Form 4, Add Maths, Past Years, SBP. Topic, quadratic function. The straight line y equals 2x minus 3 does not intersect with the curve y equals 3x squared minus x minus q. This curve is actually quadratic function. Question, find values of q. So I just did step 1. I collect back that the y equals 3x squared minus x minus q is a curve. Because the x squared is positive, the curve is U-shaped, and then it says does not intersect with the straight line y equals 2x minus 3. And the question is asking q. For this question, we need some notes. The quadratic function fx or y ax squared plus bx plus c1. So this quadratic function and a straight line ax plus by plus c equals 0. This one should put as a c2 because I have here c1. And this straight line, you must change it to y mx plus c2. You must change form. The straight line given in this standard form, you must make the y subject. And the notes is, the quadratic function and straight line can intersect at 2 points. Therefore, b squared more than 4ac. The quadratic function and the straight line intersect at 1 point. b squared equals 4ac. And the quadratic function and the straight line does not intersect. b squared less than 4ac. Now the problem, to find the ABC for all these, you need to take the y of the straight line, which is mx plus c2, substitute in the y of the quadratic function. Take the y of the straight line, put inside the y of the quadratic function. So here y, I replace with mx plus c2, and after replacing, you must transfer all the left hand side to the right hand side so that we can get 0. You must get 0. Take the y of the straight line, put inside the y of the quadratic function, transfer everything to get the 0. So I would have ax squared, the original one, plus bx, mx I transfer, become minus mx, and then I have my c1, and finally c2 transfer, I get minus c2. And here, the x is in 2 places, so I must factorize. I take out the x, inside brackets, b minus n. The others I just copy back, ax squared, c1 minus c2. Now the ABC, the a as usual is in front of the x squared. The b is b minus n in front of the x. And c is the last term without x. So for our question, we were given y equals to 2x minus 3. I take this y, substitute in the y of the quadratic function, which is 2x minus 3. And on the right hand side, I just copy back 3x squared minus x minus q. Over here, 3x squared minus x minus q. Now, I'm going to transfer the 2x minus 3 to the right hand side. So 3x squared, just copy back. The 3x squared minus x, I just copy back. And then the 2x I transfer, minus 2x. And then the minus 3 transfer becomes plus 3. And don't forget to copy back the minus q on the right hand side. So now 3x squared just copy back. You watch here. Huh? Minus x minus 2x is minus 3x. And finally, the 3 minus q, I just copy back. Now, our a in front of x squared is 3. Our b in front of the x, negative 3. And our c, 3 minus q. Remember, the question said, does not intersect, which is here, does not intersect. So, does not intersect, b squared less than 4ac. So, does not intersect, b squared less than 4ac. All we have to do, substitute. That's all. Our b, negative 3, don't forget square, less than 4, a is 3, a is 3, and our c, 3 minus q, 3 minus q. So now, negative 3 squared is 9, less than 4 times 3 is 12, and the 3 minus q, I just copy back. And of course, the 9 and the 12, I can divide by 3. I'm going to get 3. 9 divided by 3 is 3. 12 divided by 3 is 4. And the 3 minus q, I copy back. Now, on the right hand side, expand. 3 times 4 is 12. 3 times minus q, 4 times minus q. 4 times 3 is 12. 4 times minus q, minus 4q. I transfer the negative 4q to the left hand side. 4q less than 3 transfer to the right hand side. 12 minus 3. And 12 minus 3 is 9. So I have 4q less than 9. The 4 transfer to right hand side, divide. So my q less than 9 over 4. Okay, this is quite a long question, and please don't forget these notes. This notes is critical. Whenever you have intersection between a curve and a straight line, remember the 3 things. And the main story is, to find the ABC, you must take the y of the straight line, put inside the y of the quadratic function, transfer everything so that one of the side is 0, simplify, and then in front of x squared is a, in front of the x is b, and then the last 2 numbers is c. So you take the ABC, you substitute according to the situation. Whether it intersect at 2 points, this, intersect 1 point is this, does not intersect is this. Okay, that's it. And final answer was q less than 9 over 4. Thank you. I see you.